Hey everyone, welcome to the notes on 7.1, integration by parts. We're going to think of integration by parts as the product rule for integration. So if you have an integral and it's got two different things in it, so how would I integrate that? Well, let's start off with this. We're going to call one of the two things u, like u substitution. We're going to call the other one dv. Once you know what your u and your dv is, here's the formula. uv minus the integral of v du. So, the hard part is to figure out which one to call u and which one to call dv. Because once we have our u and our dv, the rest of it's a simple formula. Well, which one is u? There's a little thing to remember to help you. It's called Lipit. Logs. If there's a log in the problem, that's u, and the other thing is dv. If there's no logs, look for inverse trig functions. If there's an inverse trig, like arcsine or arctangent, that's u, and the other one's dv. If there's a polynomial, x squared, x cubed, x to the fourth, call that u, and the other one dv. If there's an exponential, and there's nothing else, call that u, and then lastly trig, sine, cosine, tangent. So we're going to go in this order when it comes to what we call u, and then the other one is going to be dv. Much easier in practice, so let's try one. This is a product rule. I've got this is one function, and this is another function. So I'm going to use integration by parts. But the question is, which one do I call u, and which one do I call dv? Well, there's no logs. There's no inverse trig. There is a polynomial. X is a polynomial, so this is going to be my u. So u is going to be x, which means dv is going to be cosine x, dx. But if we're going to do this, we also need to know what du is, and we also need to know what v is. Du is easy. The derivative of x is just 1, so that's not too hard. But what's v? What's the integral of cosine x? Sine x. So now our formula says u dv equals uv minus the integral of v du. Well, let's plug in what we know. U is x, v is sine x, minus the integral of v sine x, and then du is just 1, so I don't need it, dx. So now if you take a moment and look at what we've just done, you'll see why integration by parts is so useful. I took an integral that had two things in it and rewrote it as a problem with an integral with only one thing in it. Now this is much easier to solve. That's just x sine x. What's the integral of sine? It's negative cosine. Negative negative is plus cosine x. And because this is an indefinite integral, it has to have a plus c at the end. So that is integration by parts. Figure out what to call u, dv, and then the rest of the problem is pretty simple. Let's try another one. This is integration by parts. Which one do we want to call u? Well, it's going to be x again. Du will be 1, and that's good. That means that something's going to cancel out. dv is e to the x dx. What's v? Well, e to the x is really easy. It's its own integral and its own derivative. So now let's follow the pattern. It's u v minus the integral of v du. But du is dx. Now look at what we have. We took an integral with two things and turned it into an integral with one thing. So let's integrate it now. X e to the x minus the integral of e to the x is really easy. It's e to the x plus c. Integration by parts. Let's try this one. This is a definite integral. What are we going to call u in this problem? We're not going to call u x. Remember, Lipit. Log comes first. So natural log of x is my u, which makes du 1 over x dx. Which makes dv x, which makes v 1/2 x squared. So let's go through this. This is u, natural log of x, times v, 1/2 x squared, minus the integral of v, 1/2 x squared, times du, which is 1 over x dx. From 1 to 4. Let's clean this up a little bit. This is 1/2 x squared, natural log of x, minus integral from 1 to 4 of, I'm going to pull the 1/2 out front. This squared and that x will reduce down and just give me x dx. Now that's a much, much, much easier integral. If you integrate that, you get 1/2 x squared, natural log of x, minus 1/4 x squared. Not plus c in this problem. It's not plus c because I have bounds. My bounds are 1 to 4. So let's plug in what we know. If we plug in 4, that gives us 16 and 8, so that's 8 natural log of 4 minus 16 and 1/4 is 4 minus, if you plug in 1, the natural log of 1 is 0, so it doesn't matter, minus, plug in 1, you get 1/4. Cleaning that up a little bit, you're going to get 8 natural log of 4. Negative 4 plus 1/4 is negative 15/4. So that's integration by parts with a definite integral. Let's try this problem. And I'm going to do it by the long way, and then I'm going to show you a shortcut. So hopefully by now you know that u is x squared, du is 2x, which makes dv e to the x, v e to the x. So my formula says it's u v minus the integral of v du. And let's stop and look at what just happened. Normally I take two things, and when I do integration by parts, I get down to one thing. But this time I still have two things. I have to do it again. Call u 2x dv e to the x, du 2v e to the x. So my problem is still going to be x squared e to the x minus, but now I've got another u substitution problem. Or I'm sorry, another integration by parts problem. u v minus the integral of v du. Now let's clean this all up. That gives me x squared e to the x minus 2x e to the x. Minus and minus is plus 2e to the x plus c. Sometimes you have to do integration by parts more than once. Sometimes you have to do it multiple times. As a shortcut to that problem, I want to show you something called the table method. The table method looks like this. Make a table. And on this side, you're going to put u. And on this side, you're going to put dv. So my u is x squared, and my dv is e to the x. This is u when we need all the derivatives until we can't differentiate anymore. This side, we're going to integrate. So derivatives on this side. On this side, integrals. This one's easy because the integral of e to the x is e to the x. So how does this help us? Well, now the pattern looks like this. I'm going to draw diagonal lines, and I'm going to put plus, minus, plus. And if I kept going, it'd be minus, plus, minus, plus, minus. Now take a look at what I've got. A positive x squared e to the x, a negative 2x e to the x, a positive 2ex plus c. I get the same answer I did by doing integration by parts the long way. This is a way to go faster. So why don't we do this all the time? I'll show you in a second. I would recommend this method for when you have more than one step. But again, you'll see it's the same answer. So when does the table method not work? Problem like this. The reason the table method works is one of these two things will go to 0 when you take enough derivatives. This one will not. E to the x will never go to 0. Cosine of x will never go to 0. So Lippitt says we're going to call u e to the x, which makes du e to the x dx. So now I've got dv equals cosine x, and v equals sine x. This is long and a little confusing, so let's pay attention to what we're doing here. We've got the integral of e to the x cosine x equals u v minus the integral of v du. As expected, nothing canceled out. So let's do u substitution again. U is equal to e to the x, which makes du also e to the x. dv is sine x in this problem, which makes v negative cosine x. So now I've got e to the x cosine x, forgot my dx, equals e to the x sine x minus u v minus the integral of v, negative cosine is cosine x, negative makes that positive, du. And you can see this is going to keep just going back and forth between sine and cosine. But let's stop for a second and take a look at what my problem is right now. I've got e to the x cosine x dx. That's my original problem. Equals e to the x sine x plus e to the x cosine x minus the integral of e to the x cosine x dx. And no matter how many times I do this, I'm never going to cancel out the integral. So how in the world could I ever solve this? Well, let's think about some basic algebra. This is what I want to know the answer to. I want to get this equal something without an integral. Take a look at this right here. It's the same thing as this. So I'm going to add it to both sides. Legal because I'm doing the same thing to both sides. I don't know why I didn't put x right there. So now my problem says 2 times the integral of e to the x cosine x dx equals e to the x sine x plus e to the x cosine x. We're almost done. How do I get this by itself? Because this is what I want to solve. Divide by 2. Divide by 2. And that's my final answer. Oops, I'm missing one thing. What am I missing? Plus c. So, in a problem like this, the table method won't work. No matter how many times you do integration by parts, it won't work. But what happens is it wraps back on itself so that you have this on both sides. Get them all on one side and solve. That's integration by parts. There's more practice problems out there, plenty of time to try this. If you have any questions, come talk to me. Thanks.